Hello there, thank you for joining me again today. On the bench for a review and test is the radio, a President Lincoln, also known as Uniden 2830 in certain circles. This is effectively a ham radio transceiver that was more of a hybrid into CB radio as well, which we'll go into in a moment. But what we'll do, we'll look at the radio and its features, and we'll also test it on the Marconi radio test instrument there, and do a spec test on it on all modes. Now, this is where it all started for me, really, insofar as getting into radio, and I thought I'd do a little bit of a feature on the Uniden and CB radio systems throughout the 27 megahertz range, 934 megahertz range, and also the standard CB radio as well. But basically, when I was quite young, about 8-9 years old, how I got into radio was on the CB, would you believe? And this is the type of radio that I had back then. This is a York CB 2781, which is an FM radio, because back in the day when I was quite young, there was a lot of AM radios about here in the UK, but they were made illegal, and then obviously FM CB 2781 regulation came out in 1981, but AM radios are still in use for quite some time, albeit illegally, on the CB radio band. So really I started with one of these, just a basic CB. It does 4 watts on transmit on 27 megahertz, which is a frequency allocation for the UK CB radio band, or the worldwide band for CB. And I had one of these for donkey's years when I was younger, and I ended up basically cutting my teeth in radio on these. And over the years I ended up with lots of different CB radios, including Murphy Home Base, Rotel 240 I think it was, Cobras, loads more radios, and they all did different bands and sub-bands of the CB radios, frequency allocation like half channels, USB, LSB, AM and FM modes. I had all the different types of radio, but most of the radios that I had back when I was young, about 10 to sort of 12, 13 years old, were all this type of radio. It had a channel readout, channels 1 to 40 or 1 to 80 if it was modified, if it had the half channels on. And basically, to cut a long boring story short, when I had my CB radio, I made lots of contacts on the radio, indeed worldwide contacts, many worldwide contacts, even on 4 watts, which was, you know, for me quite surprising. And I had an antenna at the time. Well, I had lots of aerials. I had a Sigma 4, I always remember that one, because it was like a basket, a V basket at the bottom, like an upturned shuttlecock, really. So you had this basket at the bottom that stood about 6 foot high, made of aluminium rods and like a sort of like a loop round circular aluminium disc at the top. And then you had the long vertical wick that stood up in the middle. It was quite a thick pole at the bottom, and then it got narrow as it got to the top. And I always remember as about 10-11-year-old asking my dad to put that antenna up, and he wasn't very happy at all about putting that aerial up on the house because it was massive. It was bigger than the house, and it stood about 30 foot tall, did the whip. And of course, anybody who knows about wavelength in meters, it's quite an easy calculation to do. It's 300 divided by frequency gives you the wavelength. So 300 divided by 27 megahertz will give you the full wavelength of the 27 megahertz transmission. So you can work out from the 27 megahertz frequency and that formula what the meters in wavelength that you'll need to make an element for in length, you know. So you know, it's just like amateur radio band 70 centimeters, 300 divided by 433 megahertz gives you, I think it's 69.7 centimeters, hence the reason why it's called 70 sems. 2 meters, again 300 divided by 144 gives you equivalent to 2 meters in wavelength, hence the reason why it's called 2 meters, etc. So if you're making an antenna on CB to get a full wavelength, and as we all know with aerials, there's quarter wavelength, half wave, 5/8 wave, 3/8 wave, then there's full wave. So the nearer you can get to a full wave antenna, the better the transmission, obviously, or the gain of the antenna will be. And so I had this Sigma 4 antenna, this big basket thing at the bottom that stood about 6 foot tall, and then this huge whip of about 30-40 feet long. And I mounted it on the house, and much to the disgracefulness of my father with it, he wasn't happy at all about me mounting this antenna on the house with all the brackets and everything, but nevertheless he helped me do it. And I drilled a hole through the bedroom window, wood frame, to get the coax through, and then to my CB radio here. And I could get out all over the place. It was brilliant, and I managed to speak to loads of people, made loads of friends on CB, and talked all over the world, and got QSL cards off of people from Canada and North America and most of Europe and other countries as well, aside, in summer with the lift conditions, and learned about, the atmospherics and the effects that atmospherics have, stratospherical ducting, sporadic E, MUF, maximum usable frequency, ionospheric ducting, all the different types of properties that the atmosphere can influence radio signals with. I cut my teeth on CB radio. And so eventually, when I was in my mid-teens, I went to this radio below, this is called the President Lincoln. Now, the radio that's identical to this in every way was called the Uniden 2830. And the Uniden 2830 was a ham radio version of the President Lincoln. And the reason why it was called Uniden 2830 is because obviously it did just 28 to 30 megahertz. Whereas the President Lincoln does 26 megahertz to 30. So the President Lincoln was actually a hybrid between CB radio and 10 meter ham radio. And so at the time I wasn't a radio ham, I was just a CBer. And when I first got one of these radios, this President Lincoln thing, it was like the Starship Enterprise, and it had a frequency readout, which was totally new to me because obviously I was working with channelized radios, so I had no idea about the frequencies for what that equaled in channel number. So then I had to get a band plan with all the channels and the frequencies. And also this does all the modes. It does AM, FM, USB and LSB, upper sideband and lower sideband, as well as CW for Morse keys. So this radio was like fantastic. And bearing in mind, I was only about 10, 11, 12 years old, I think, when I got one of these. So this was like the bee's knees. And anybody who owned one of these always had good reviews of them, and they were very good at reception, the sensitivity of receiver. The transmitter did 10 watts on FM, whereas the ordinary CB did 4 watts if you were lucky. And so this was a more powerful radio in all aspects. It did far more than the standard CB did. So I enjoyed using this for many years, and I think it was illegal actually to use these at the time, and probably still is, because they did all modes. Certainly on the CB frequencies, I think on the 26 mega band as well as 27, I think it was a bit dicey if you weren't a radio am using one of these on all modes, because I think the CB 2781 regulation made it so that CB was limited in its RF output power at just 4 watts, and then you could only transmit in FM. So correct me if I'm wrong in the comments by all means, but that's how it was in the UK at the time. The government wanted to get people off AM, they wanted to get people onto FM CBs and limit the output power, whereas the President Lincoln did away with all that. It opened the world up for DX with having sidebands on, and also the fact that it had the frequency readout and it could scan, which a CB can't scan, you see. This type of CB can't anyway. And this can scan frequency bands as well as channels, so it was easier to pick up conversations without never-endingly turning the channel knob all the time to search for active channels. So this radio was very, very good at the time. It was like a cross between a scanner and a CB, all integrated into one unit. and I really enjoyed using the President Lincoln for many years. As I say, I had various models of CB before this, including the Murphy home base, I think it was, Rotel, Cobra, and various other makes. There were lots and lots of makes. And it's interesting, even today, there are people, particularly in the United States, companies that are specifically into restoring CB radios, and they have started doing these very, very good modifications where there's like a signal meter, like we have there, an analog S meter, but there's an OLED display just below it that shows you the frequency in like a really good contextual colour, and the switches all light up, and the knobs are all backlit, and they've got all these really nice light features on them, and all kinds of spec, and they do higher output power on RF as well for the truckers in the USA. You know, they do considerably more power than they're meant to do, and it's sort of, you know, there's a bit of a following. There's a company in California, I think, I can't remember the name now, but they did the Smart Trunk radio system originally. They took that company over, and they mainly do CB radio specialist builds and bespoke designs. So there's still a big following in it even today. But you know, this radio, the Uniden 2830, the President Lincoln, it was just like unbelievable. And of course that's how I then transitioned into ham radio. And obviously I had to sit my radio amateur exam at the time. I didn't do my A licensee, where you had to learn Morse code at 12 words a minute in order to get onto the HF bands. So there was quite a lot of people, I think, that was on these radios that didn't want to be an A licensee because they hated Morse, or they didn't want to do it, or they couldn't do it. Like me, I just could not stand Morse code. As a young person, it was an old fogies type of thing as far as I was concerned. Now, of course, I'm a lot wiser and I'm actively quite interested in Morse code. But back then, I couldn't care less about it. And then the regs in the UK at the time were in the early 1990s, late 80s sort of thing, when I did my RAE, is that you couldn't work the HF bands, I think below 50 megahertz, I think it was, 6 meters, unless you had an A license, which meant that you had to have passed the 12 words per minute Morse code, da-di-di-di-da-di sort of test. And I perhaps could send Morse, but I sure as hell couldn't hear it or read it, so I gave up with it, and I thought, sod it, I'll do the B licensee. So I became a radio ham after passing the exam and studying and doing all the work around it, and I became a radio ham instead. But long before I became a radio ham, about the time of the Uniden 2830, I had a friend who came round, who had a family member who was a radio ham who just passed on, who'd left all his radio gear, and he had a couple of old radio transceivers. But he had this Yaesu radio transceiver, and I'd never seen these type of things before when I got this, because I was still only about 12, 13 when I had this radio. But basically, this is long before I did the radio AM exam, obviously. I ended up with this really fancy radio being brought round, and it just blew my mind, and this is the sort of thing that I had. So this is the sort of example that he brought round, and this was just unbelievable when I saw this. It was a Yaesu transceiver, not as modern as this one, might I add. It had a lot more older style buttons on it and knobs, and it was a more of a grey colour, but it was very advanced like this radio is in comparison, and it did HF, VHF, UHF, it did several HF bands as well, not just 0 to 30, I think it did 6 meters as well, 50 megahertz as well as 2 meters, 144 and 77s, 430 to 440. But it was just like unbelievable, this radio. When I saw it, it was just like an alien civilization had created this type of radio. And bear in mind, this is before I did the RAE exam, probably about 5 years beforehand. And I thought, wow, this is absolutely fantastic. And I thought, I'm going to have to get into this, you know. But this radio that he brought had a different plug on the end. It was an N-type, a few N-type connectors, and I think one SO239. So I could only initially connect the Sigma 4 CB antenna that I had at the time, that I was using for the other CBs that I've shown you, into the HF side. So I couldn't get VHF UHF working because I didn't know how to fit an N-type plug on the end of RG58 coax, and of course that was all new to me, and I had to learn how to do that, and I did it fairly quickly. And then I had to get another aerial for VHF, another one for UHF, and we started to faff about with the radio and pick, you know, repeaters up which I'd never heard before. That was something else when you transition from CB to something like that. Even before I did the RE exam, and you were listening to the repeaters, and I had scanners at the time, and I used to listen to radio AMs as well through radio repeaters. But as a young person, it was quite interesting to try and understand how repeaters worked. So to be able to transmit on the amateur band, which I couldn't do before on VHF and UHF, and this radio allowed me to do that. And I must confess, even before I got the radio AM exam, I did used to broadcast on the radio, but obviously I didn't have a call sign, you know, but I didn't cause any problems to anybody. But that's how, you know, you learn anyway. But I got quite into it. I got a VHF and UHF antenna, and I did monitor radio transmissions on it and listen to people, and I started to get into the functions. And this radio as well did sidebands. It did CW, AM, FM, just like the President Lincoln does, but it did it on all frequencies, not just the one. So I was really getting into HF as well, below 30 megahertz. Obviously there's more propagation further down the bands, and that sort of supplemented my knowledge in that area. But around that time as well, when my friend brought this radio transceiver around for me to borrow, because he didn't know how to use it, and it belonged to obviously one of his deceased family members, relatives, I also managed to get one of these as well, which is a 934 megahertz radio. And the 934 megahertz radio was really interesting because at the time, in the late 80s, the UK government was trying to transition away from analog cellular on the 904 to 936 megahertz frequency allocation, and they wanted to expand the frequency band up to 960 megahertz for cellular. And at the time, all the cell phone conversation that took place on the European cellular frequency bands at 900 megahertz on TACs and ETACs systems were in analog, and so they were doing away with that and going on to GSM, GSM version 1, if you like, the original EGSM. So it meant that these were unfortunately going to lose their frequency allocation, and so the price of these radios dropped dramatically, and it came into my pocket money range. So I'd saved up my pocket money, and I managed to buy off of somebody I knew who had one of these, who was getting rid of it, another CB radio enthusiast who had a 934 megahertz radio. I bought this very cheaply because just shortly before, that's when they announced that they were going to get rid of the band and make it illegal for anybody to use it, and one thing or another. But surprisingly enough, in the short time that I could use it before everything changed, I had quite good contacts with it, and I ended up buying a 934 megahertz omnidirectional antenna that I mounted on the chimney stack of a house and ran the coax down the roof and into my bedroom, and managed to get going with that quite well. And that got surprisingly very good distance contacts on it, more surprising than you'd think. And you could get very, very far contacts with this on FM on 934 megahertz, particularly around about August time, July, August, when the lift conditions were on certainly the UHF band. You got really good distance with that. So I had this radio for quite some time, very enjoyable. Not this exact radio, but one very similar to it, because I still buy radios like this when I see them, even now. But it was a very interesting hobby, that 934 megahertz, and 934 megahertz didn't work well with RG58 coax, because RG58 coax is quite lossy at UHF, particularly at 900 megahertz. So I had to buy this really expensive, again, save up my pocket money, to buy some really expensive, what they're called heliax cable. And that again was a complete new thing for me, because I'd never ever come across coaxial cable that was sort of bigger than your finger in diameter there, your index finger. So to get this coax that I think Andrews made it was quite a big thick coax, and to learn how to put those plugs on and everything else, that again was something else that I cut my teeth on. But that then enabled me then to get into the 900 megahertz band quite easily. And I think at the time as well I bought a realistic scanner, and I was listening actively to all kinds of things on the radio bands, as well as having an HF receiver, dedicated DX300 I think it was, realistic one that I had at the time, that was an awful radio, but nevertheless I used that quite a bit for HF. So obviously going over to the ham radio side, this thing was just like mind-blowing. And although I'd quite a lot of experience with, you know, the CB radios, this was a different world. So that's what spurred me on really to do the radio amateurs examination, which was a City and Guilds qualification here in the UK, sort of quite a very renowned qualification, and could indeed help you get even a job, which it certainly helped me get a job in telecoms, I'll say that. Knowing amateur radio, being a qualified radio am, passing the examination, the City and Guilds national qualification, and being an active radio amateur certainly got me in places that I wouldn't have otherwise, don't think I would have got into in the realm of electronics, radio frequency engineering and RF engineering as a radio engineer. Certainly wouldn't have got anywhere near it, I don't think, unless I'd had the radio am. So that paved that way into that industry for me. Before then I started to build my career. So, you know, it's a very worthwhile thing to do, I think. But anyway, as the years progress, obviously we still keep with it. And although I do meet people from academia, the people who are PhD qualified, who have been to university, who have developed fantastic products in the world of RF and electronics engineering, in radar technologies and deep space communication networks, medical experimentation to do with RF influencing things like cancer cells, for example, and the medical and research and development in the engineering fields, and space and defence sectors. I always tell people when we have conversations that my journey began on CB radio, and sometimes it's quite surprising for people to hear that. And obviously ham radio as well, you know, that the journey progressed through to then still carries on to this day. And obviously radio telescopes and things that I've visited when I've spoke to RF engineers that design and build receiving apparatus and transmitting apparatus for radio telescopes, and quite highbrow scientist level of people that I meet, international exhibitions and industry leaders and people that develop things like 5G technologies, for example, and get into RF circuit design and indeed you know, mimic level monolithic microwave circuits, and to tell them your background and how they got into it. And it's quite interesting because some people come into RF electronics engineering from a purely academic background, where they've done well at school in maths, English and science, and then they've gone to university, and then they've gone from the various levels of degrees in university, perhaps up to PhD level, but never actually picked a radio up and communicated with anybody, or had that experience of using a radio to talk to somebody at the other side of the world. And although they're very knowledgeable in RF and electronics engineering, sometimes they've lost the touch that some others have, where they've had the grounding in RF through using the radio to communicate with other people and get that fundamental background behind them. And often that can catch up with them in later years as well, as you'll see later on in other videos that I'll do. But doesn't mean they're any less of a person or anything like that. I'm not saying that, but it just means that some people come into RF in different ways. I came into RF engineering through this that we just talked about now, whereas others come into it more of an academic footing, and going it that way and find their own little sector. But I've always enjoyed the variance of going from one sector to another, and having time in each sector and doing something different every few years, every decade, moving jobs and finding new challenges and new things. So it's quite interesting. You know, even today amateur radio is used very widely for those that are not into ham radio, very widely in research and development, and there's a lot of things that would not have been possible today had it not been for ham radio, amateur radio. Certainly some of the devices that we all take for granted today, mobile phone technology, in medical advances, in deep space research and deep space communication networks, radar fundamentals, all kinds of technologies that we take for granted today in our modern world do actually stem from ham radio, a lot of it. And there's a lot of very clever scientific people who have come from the ham radio background, a man in a shed, who have gone on to develop some groundbreaking technologies and science through ham radio and experimentation in RF using ham radio bands. So there's all kinds of things that you can do in ham radio, from digital to analog to design and build and every mode possible, propagation, research, moon bounce, communicating with satellites, talking to the International Space Station, for example, you know, microwave radio, HF radio, VHF, UHF, basically every type of conceivable approach to RF engineering is in amateur radio. And indeed television transmission, fast scan, slow scan TV, facsimile, all the things you could ever want to do are in ham radio. And not to mention all the digital modes and everything else to do with what we currently have available now in software defined radio. And so that's the nice thing about ham radio, is that anybody can find their own level in it, just like you can in CB radio, and you can develop yourself to whatever level you want to go to. And I think that's fantastic. There's not many hobbies in the world, I don't think, that gives that much variety, and certainly has helped me a lot over the years. And I'm never ashamed to say I started on the CB bands. I'm never ashamed to say that I'm a radio ham. And sometimes when I mention this to the scientific community that I bump into from time to time at these international events or in defence circles, sometimes the eyebrows lift. But the thing is that you should never be ashamed of your heritage. And I've always enjoyed doing amateur radio and CBs and playing around with radio gear, so it's good to do. So we'll have a look at this radio now on the Marconi and give it a test and see what it does, this President Lincoln. Right, so we're currently on the FM frequency band, well, the FM mode, and we're on 27.520. I'll probably change that to that's a spot frequency of 500, so 27.5 megahertz dead. Then we know what we're working with. Okay, so on the mic we've got the up and down, so we can do that as well, and then the PTT. So we've got the RF power to maximum, the clarifier, which I'll go into later when we do the sideband testing, set in the middle, swatch to auto, volume there, and all the rest of the buttons are all set in the correct positions. And this radio's got an inbuilt SWR power meter built in, which you can adjust using these buttons and that knob to calibrate it against a 50 ohm load, and then put it on an antenna so it'll give you a VSWR reading. So that's saved having the external accessory that people often use to buy a VSWR meter. So we'll transmit, and so basically we've got 10 watts in the top right hand corner at 27.5 megahertz there. 5 1 2 5 4 3 2 1 5 1 2 1 2 1 2, about 4 kilohertz, 4 point something kilohertz deviation maximum with a mic, but averaging about 3 something. 5 1 2 3 4 5, and we're doing 10 watts on FM. So we'll have a look now at the other mode, which is AM, and then we'll need to set the Marconi up so that it does AM, which I'm going to work out how to do now. It's been a while. It's mod type. That there, just there, mod type. And that's AM depth. So then this is a breakout screen of the test set screen. So now we're in AM mode. 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. 5, 4, 3, 2, 1, 1, 2, 1, 2, 1, 2. 73% modulation. 5, 90%. 5, 5, 5. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. So that's in AM on the transmit mode. And now we'll go over to the sidebands and set that up. So we switch to USB now per sideband, and then we've changed the radio test set now to reflect what is upper sideband. In the top right hand corner up here we've got USB selected, and everything's in as it should be, SSB-TX. So I'll key up the radio now. 5, 1, 2, 3, 4, 5, 5, 5, 1, 2, CQ, CQ, CQ. So we're getting up to nearly 10 watts there on the modulation. We're only with the carrier about what, 300 and something hertz off, if that, roughly. And then the power's going up to a maximum of about 9.5, 10 watts there as well. So that's within specification. Its frequency is correct. So that shows that upper sideband's working. We'll now switch it to LSB. So we'll switch the radio now to lower sideband, and then move the selection here for the sideband to lower sideband, as we can see up there in the top corner, and we can then transmit again. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Radio test 1, 2, 3, 4, 5. So the offset frequency is very good. Again, very similar to lower sideband. Now this radio test set also offers a suppressed carrier as well. So there's different types of SSB. There's like DSB double sideband, suppressed carrier, unsuppressed. There's lower sideband, upper sideband. There's different SSB modes. SSB is still widely used around the world in military and avionic communication. Obviously aircraft get halfway across the Pacific Ocean or Atlantic Ocean just to several hundred miles off the coast of mainlands, and the VHF aeronautical radio communication system won't work at that sort of distance, even though they might be 35,000 feet up. So they tend to use HF radio, or nowadays satellites more, but the HF's there. Used to be commonly used, but now it's a backup, I think, on mainly aircraft. But HF radio is certainly something that's still used for aeronautical communications. Indeed, it's still used in military circles, obviously, because of the distances involved and the fact that it's reliable and that it gets the job done. So make no mistake about it, SSB and USB and LSB is certainly still widely used. Indeed, in microwave radio communications as well, for particularly being able to transmit many thousands of telephone calls, for example, over a microwave link from a telephone exchange to another telephone exchange. They used to use sidebands for that, so you'd literally have each multiplex with, say, 10,000 phone conversations on it, all on their own individual sidebands, or with guard tones between each sideband. And so therefore each tribune would be able to output so many phone conversations at any one time from A to B end. So sidebands was used quite widely in microwave radio links as well, particularly for very long distance microwave links, because obviously it's a mode of transmission other than what is QAM, quadrature amplitude modulation, or QPSK, quadrature phase shift keying, and other digital transmission modes like SDH, for example, that's used on microwave links. As far back as the 1950s, 60s and 70s, companies around the world, telephone companies, used to use sidebands over microwave, so that the signal will propagate much further on sidebands, and thus microwave links could be further apart. And indeed it offered the bandwidth that was quite narrow in the allocations that they had. It afforded more information to be conveyed in the smaller bandwidth through using sidebands. So make no mistake about it, sideband is still very much in use in many ways, and it's very important for worldwide communication, which wouldn't be possible on other modes on the same frequency. So that gives you a little insight into that. So we'll hop over now to doing receiver testing, starting on FM and going right the way around to upper sideband again. Yeah, and of course marine radio uses sidebands as well quite a lot, especially for international shipping, for communication as well. So that's something you might find on marine radios when you get them. The scanty HF radio, for example, which a lot of the Coast Guards use, and they're big powerful transmitters with the digital control panel on them. You'll no doubt see scanties as time goes by if you look round for them. Coast Guard stations mainly use those. They're on HF, a lot of those, and they broadcast at quite a few 100 watts output power and sidebands to communicate with ships and vessels way out in the oceans around the world. So, and indeed telephone patching used to be used. I think the Italians used 8 point something megahertz, I think it was. I used to pick up phone conversations that were telephone patching from ship to shore on sidebands. I couldn't understand what the conversation was about because it was in Italian, and I don't understand Italian, but used to do all sorts of weird things. And of course the United States Air Force and other militaries around the world use HF for emergency action messages for their strategic nuclear bomber and alerting mechanisms for around the world communication, just like the Russians do, and the number stations and all this intelligence stuff that goes on around the world, and spying and everything else. HF's used quite regularly for that, and of course radio teletype as well. News agencies around the world use upper sideband and lower sideband on HF for transmitting news information and things as well. Particularly from outside of from countries that don't have the internet or haven't got that capability, or that it's just straight communication. Embassies use HF radios with LSB and USB to communicate with their the home countries, and all kinds of things going on HF that are really quite clandestine. But as well as that, it's great for talking on ham radio wise. Now we've gone back to FM. We've set the receiver up now on the Marconi. We've got a frequency there with a level of neg 96 dBm, plus or minus 2.5 kHz deviation at 1 kHz tone. So if I turn the volume up now to test the receiver spec, we've got it there, and we can test that spec now on the Marconi by adjusting the RF level. So I can just get to this knob, then we can begin to wind the RF level down, see how sensitive it is. So it's quite good, 113 dBm, good 0.1 of a microvolt when it squelches out. Now, obviously, with it being a HF radio, if I set the squelch to auto from manual adjust, the squelch will probably be set tighter, and we've got a signal meter here as well. So if I just adjust the signal again, there we are, about neg 100 dBm it'll squelch out at. Now you've got to bear in mind, of course, when this is used, this radio is used in its capacity connected to an HF antenna, the noise floor is going to be substantially higher with all the electrical interference that contaminates the HF band. And indeed the squelch level, although it's very sensitive, a receiver, if we were to leave the squelch set too sensitive, it would lift the mute with the RF noise in the HF band. So that's why the squelches in the auto position are set quite tight on these. So in other words, you want a really good quality signal to be present before the mute will open, although you can manually override that with the sports control and adjust it to what you want. So that's pretty good, but very good receiver sensitivity. Some CB radios squelch out much higher than that, where we saw it get down to about neg 120, neg 121 dBm before the signal became unintelligible. That's about 0.1, 0.2 of a microvolt. So its receiver sensitivity is very good on this radio, whereas other CB radios are more deaf, and it may go around about 0.3 to 0.5 of a microvolt depending on how well they're tuned up. But this radio is very good at its receiver sensitivity at that. So that's another thing about this radio as well, is it has a higher selectivity because it's got extra crystal filters in it that filter out the unwanted components from the IF, and the mixing stages means that it's got better selectivity. So powerful signals that are near the signal or the frequency you're wanting to listen to won't cause as much interference than what it would say on a different type of radio that hasn't got that type of filtering in it. So there's a lot more technology in this than the standard CB. So we'll do AM now and see what that's like. Right, so we'll flip that to AM. We're still transmitting an FM carrier. We'll need to change that now. We need to set the mod gen, RF gen, mod gen level 60%, and then the percent key which is there. So this is testing the AM. So we've got demodulation of AM at 60% mod, which is what we normally do when we're testing AM radios. Put 60% mod on, and then we'll do the RF gen level. Pretty good sensitivity. I mean, neg 110 dBm roughly before it starts to quieten. So that's very good. So we'll move on to the upper sideband now, as it USB. Now on sidebands we've got the clarifier, so leave it in the middle position. So on here now I want to go to I think it's RF test, then I want to do SSBRX, I want to do, is it upper sideband? Yeah, I want to do upper sideband. So we're generating the RF carrier frequency. We've got an offset of 1 kilohertz, a mod frequency of 1 kilohertz, and the RF level at the moment. We're on upper sideband and we're not suppressing the carrier. So now I can adjust the clarifier to tune in the 1 kilohertz tone. So you can tune in the 1K tone. You can change the offset as well. So you can clarify in the signal. So that'll be the 1 kilohertz tone position roughly. So that's where we'd hear that 1K tone normally at that position, and that's how we tune somebody in on that frequency who was talking, so the speech was right. Otherwise they talk either like Donald Duck or they talk like somebody who's got their scrotum trapped. So either way you can tune that in. Obviously we can't do that on upper sideband, or lower sideband rather, not unless it's over there. So now we can generate a lower sideband signal, an LSB. So we can do that now by doing that, flicking it over to LSB. can tune it in. Get the 1K tone. So you could calibrate the radio so that when that's in the dead centre position, that's when you're getting the 1 kHz tone, which you might want the dead centre. This is slightly offset to the right, so perhaps you could do with tuning, but basically you'd want to have that mark dead in the middle for that 1 kHz tone to be recovered from the radio. So that would mean then that 27500 LSB with that clarifier set to the middle position, that the 1 kHz tone is in perfect frequency at that point. Then if somebody is slightly off frequency either way, then you can adjust the clarifier. But here, in order to get that 1K tone, sounds more like 500 Hz there it's out by. It's about there is a 1 kHz tone, roughly in that area. So it's a bit out, just a bit out, that radio. Not by much, only a tiny fraction, nothing to worry about. Now the CW one at the end is, you can use this then as a BFO to then get a Morse frequency. So then you can adjust the frequency to whatever you're comfortable with, and then when the carrier comes up and down with the Morse code, then you'll hear that tone go da di 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 da di da, like that. You can do that with CW mode. So that's what that's for. So yeah, very nice little radio, and got obviously a nice signal meter as well. It can scan, so you can set it to scan, and it'll go for all the frequencies when that's in the I think it scans mainly in FM mode or AM, but that's it. Starts to scan there. We've obviously got several buttons on the front as well. We've got dim, so we can dim the display. The span button as well, so you can change the span when we're in VFO mode from 26 to 27, 27 to 28, 28 to 29, 29, 30, etc. There's a beep tone on and off button, a band button, so each time you press the band it'll change frequency, and then obviously go right down to 26. There's a frequency lock button, so you can't adjust the frequency. Then there's a channel up and down button as well, got 50 memory channels on it. There's a local and DX button, that just puts like a 10 dB attenuator on the receiver, a mic gain, so you can control whether the microphone's sensitive or desensitive, and then there's the indicator where you can switch between VSWR. So if I key up now, it should be a near perfect match, and then you can use this pot to calibrate that, and then when you then use a radio with an antenna from a 50 ohm load as a reference, then it'll give you the standing wave ratio. So that's really that bit. Then over here we've got what is the PA, so you can use it as a public address system where you can connect a tannoy speaker onto the back of the radio, and the audio amplifier in the radio will use it as a public address. Then there's a noise blanker, which is good in sideband mode. It takes a lot of the noise, ignition noise out if you're using it mobile in a vehicle or where there's high level interference. We've got auto squelch and a squelch adjustable control, volume as well, and then the on off switch as well, so it switches it off. And that's about it really. The microphone's got a up and down button on it, so you can obviously go up and down the channels as well, so you can do that. So really good little radio. Fully recommend anybody who wants to get one. Round the back it's a fairly chunky heatsink on the back for the RF power amplifier, SO239 and a DC jack, and then you've got that multi-way connector there where you can connect external speakers and things like that up to it as well. So, and I think there's also somewhere on it an earphone socket, although I've not seen it on there, so it might be through the mic socket on the front. There might be low level audio available. So yeah, very good little radio fully recommend one if anybody wants to buy one. They're very good radio to have in the workshop, and good to listen to, and listen to other people talking on the HF bands for 10 meters, and for the CB radio band, very good. And so is all the other stuff. It's quite good as well. So if you're not already into it, why not get into it? And you never know, you might like it. So with that, that's the end of the video. Thank you very much for watching. There'll be more videos on the 934 megahertz radios and other CB radios I'll do testing on, and PMR stuff, so plenty more to come. I just thought this video would make a change from doing the RF test equipment maintenance and repair videos and the wider RF subject. It's nice to look at a radio once in a while and see how it works. So 7.3s for now, and thank you very much for watching. See you next time.